In this video, we're going to look at the problem on page 6 of the chapter 2, section 2 slides. Here we have a system of linear equations in 3 variables with 3 equations. And those equations are 2x plus 4y plus 6z equals 22, 3x plus 8y plus 5z equals 27, and negative x plus y plus 2z equals 2. The first thing we're going to do here is to multiply our first row by 1/2, because that's going to get rid of our coefficient on x there. We want that to be a 1. So if we divide by 2, that'll get rid of that. Plus everything here is divisible by 2. Everything in the first row is divisible by 2, which makes this much easier to work with. So we take 1/2 row 1, and we get x plus 2y plus 6z equals 11. A much nicer equation. We still have 3x plus 8y plus 5z equals 27, and negative x plus y plus 2z equals 2. So our next step is to get rid of the 3x in the next row. So we'll just take row 2 minus 3 row 1. Okay, well, that's going to give us x plus 2y plus 6z equals 11. That's not going to change. Then our 3x is going to go away. And we're going to subtract 6y. 3 times 2y is 6y from 8y to get 2y. And we're going to subtract 3 times 6z. I want to double check something. That should have been a 3z there. That. There we go. Sorry, I'm still getting used to this smartboard. So we're going to subtract 9z from 5z, which will give us a negative 4z. And we'll subtract 33 from 27. 27 minus 33 is negative 4. Sorry, it's negative 6. My bad. And that's really helpful to us. Makes things so much easier to work with, because this row is now entirely divisible by 2. Okay, so now our last row stays the same for the moment. We'll fix that in the next run through. Negative x plus y plus 2z equals 2. So now we're going to add rows to rows 1 and 3. Should we do it the other way around? We put the row that we're changing first and the row that we're adding second. So row 3 plus row 1, our first row stays the same. X plus 2y plus 3z equals 11. 2y minus 4z equals negative 6. And now, doing this, we're going to get rid of that x completely. X plus negative x is 0. We've got 2y plus y is 3y. And 3z plus 2z is 5z. And finally, 11 plus 2 is 13. Our next step is going to be to divide row 2 by 2, or take 1/2 row 2. When we do this, we get x plus 2y plus 3z equals 11. That's not going to change. Y minus 2z equals -3. And row 3 doesn't change. 3y plus 5z equals 13. Our next step will be to subtract 3 row 2 from row 3. So that's R3 minus 3R2. Our first two rows don't change. Especially if I look at the right matrix or the right system that I'm working with. Okay, well, if we subtract 3 times y from 3y, we get nothing. So that stays the same. We add, we're going to add 6z. -3 times -2z is 6z to our 5z. I get the just making sure that I've done everything right so far. Yep. Yes, so we'll get 11z. And that's going to be equal to, we're going to subtract 9 from our 13, or we're going to add 9 to 13, which gives us 22. And that's great. So our next step is going to be to divide row 3 by 11. And I'm going to copy and paste this to the next slide. Up there, and we're good to go. So next, multiply row 3 by 1/11, which gives us x plus 2y plus 3z equals 11. Y minus 2z equals -3. And z equals 2. And that's great. That is what we want here. We want something nice and simple. We're not always going to get simple values for these, but we did this time. So since z is 2, we can now get rid of the z's in the first two rows. We'll do this by adding 2 row 3 to row 2. R2 plus 2 row 3, 2R3. Okay, our first row stays the same. X plus 2y plus 3z equals 11. Y is going to stay the same because there's no y in row 3. So we've got our y here, but 2 times z is 2z, and we're adding that to -2z, so that's 0. That cancels out. And we have 2 times 2 plus -3. So that's 4 plus -3 is 1. Y is 1. And z is 2. And now we just need to figure out what x is. And we can do that pretty easily. We'll start by subtracting 3 row z from row 1. So that's going to give us x plus 2y. Get rid of the 3 z's, and we subtract 6 from 11. That's 5. Y equals 1, and z equals 2. Finally, we subtract 2 row 2 from row 1. And this will be our final step, and we'll have our solution. If x, we take 2 times y from 2y, and that gives us 0. So this is just x on the left. And then we have 2 times 1, subtract that from 5, and we get 3. So x equals 3, y equals 1, and z equals 2. And there is our solution. We could write it as the ordered triple 3, 1, 2 as well. Either way works. That's all for this video. Let me know if you have any questions.